Hi everyone, this is Professor Oaks, and this video is about complex fractions. Alright, so here is a complex fraction here. It's fractions within a fraction, alright? So we have 2/3 plus 1/5 divided by 7/5. So I actually would write it exactly how I said it as a division problem. So 2/3 plus 1/5 divided by 7/5. Then inside the numerator, or now this first set of parentheses here, I'm going to add 2/3 plus 1/5, and so I'm going to do that by finding a common denominator. So that would be 15. So I can get that by multiplying the first fraction by 5/5 and the second fraction by 3/3. So I have 2 times 5 is 10, so 10/15 plus 1 times 3 is 3, so 3/15. Then divide it by 7/5. Then I will do the adding here. So I have 10/15 plus 3/15. That will be 13/15 divided by 7/5. And then when I divide fractions, I just multiply by the reciprocal of the divisor here. So this will be 13/15 times 5/7. And then I can go ahead and I can cancel or divide out any common factors. So if I look at this, well, 13 is just 13 times 1, but 15 is actually 3 times 5. And then 5 is 5 times 1, and 7 is 7 times 1. All right, so then I can see that I can divide out a common factor of 5. So I have 13 in the numerator, and 3 times 7 is 21 in the denominator. So it's 13/21. All right, so let's do the same thing for the next problem here. So we'll treat this complex fraction here just like a division problem. So it's x/6 minus 5/18 divided by 7/12 minus x/3. So I have to do the subtraction inside of this set of parentheses and the subtraction inside of this set of parentheses next. All right, so I know that for 6 and 18, the least common denominator would be 18, so I'll multiply the first fraction by 3/3 so that the common denominator will be 18. So 6 times 3 is 18, so I have, actually, what do I have here? I have x3, or 3x, minus the 5. All right, and then over here, I see that I have a 12 and a 3, so the least common denominator is 12 if I multiply the 3 by 4. All right, so I have 7/12 minus x4, or 4x/12. And then let's do the subtraction here. So I have 3x minus 5/18 divided by 7 minus 4x/12. And then I do the division, so I multiply by the reciprocal of 7 minus 4x/12. So I have 3x minus 5/18 times 12/7 minus 4x. And then, here we go. So I will rewrite this as, all right, so I'll bring the constants in the front. So 12 times 3x minus 5/18 times 7 minus 4x. And I can see if there are any factors that can be divided out. So I know that the 12/18, if I divide out a 6 in the numerator and denominator, will be 2 over 3. So 2 times 3x minus 5 over 3 times 7 minus 4x. And then if I go ahead and distribute the constants in the numerator and the denominator, so the 2 and the 3 here, I have 6x minus 10 over 21 minus 12x. And then if I look at my answers here, let me bring up the answers here. I see that that is one of the choices that I have here, 6x minus 10 over 21 minus 12x. So what a time to be alive. All right, so now let's try another one here. So we have c over d divided by 2 plus c over d. So I'm going to actually rewrite this just like in the other one. So c over d divided by 2 plus c over d. And then I am going to work inside the parentheses here. So I'll make this 2 over 1. So the 2 is 2 over 1, and I'm doing that so I can easily, or more easily, find the common denominator, which will be d. So I'm going to multiply by d over d. So I have c over d divided by 2d over d plus c over d. Then I do the adding, so that will be c over d divided by 2d plus c over d. And then I multiply by the reciprocal here. So I have c over d times, all right, so what will this be? This will be d over 2d plus c. Then I divide out the common factor here of d. So I'm left with a c over 2d plus c. So there is my choice right here. All right, so let's try another example today. So here we go. We have 3x plus 3y over x squared minus y squared divided by 1 over x minus y. So we'll rewrite this as a division problem just like before. So 3x plus 3y divided by x squared minus y squared divided by 1 over x minus y. And then I see there's no adding and subtracting to do, but I could factor out a GCF in the numerator of this fraction here, so that would be 3 times x plus y. And then the x squared minus y squared is a difference of two perfect squares, so that will be x plus y, x minus y, divided by 1 over x minus y. And then I multiply by the reciprocal, so this is 3 times x plus y over x plus y times x minus y times x minus y over 1. And then I can divide out any common factors here. So I see x plus y divides out, and I see that x minus y divides out. So I'm left with, all right, I'm left with 3 over 1, and 3 over 1, or 3 divided by 1, is just 3. So there is our answer, 3. I hope that you're enjoying this because we're not done yet. So here's another problem. All right, so this is also a complex fraction or a division problem here. So I have 6 over a minus 3 over b divided by 2 over ab. And I have to do the subtraction in the first set of parentheses here. So I see that the common denominator will be ab. So I multiply by b over b and then a over a, so that they're both BA or AB. So then if I do the subtraction, then I have 6B over AB minus 3A over AB divided by 2 over AB. So then the subtraction then gives me 6B minus 3A over AB divided by 2 over AB. And then after I do the subtraction, I need to multiply by the reciprocal to do the division here. So I have 6b minus 3a over AB times AB over 2. All right, and then I can divide out the common factors. So I can divide out an A, and I can divide out a B, and I'm left with, well, you can see what I'm left here. I'm left with 6B minus 3A over 2. What a time to be alive. I really hope that you're enjoying this because we're not done here. So let's do another one here. All right, so what do we have here? Another complex fraction. So let's go ahead and just do the division here. So we have, let's see, this is going to be 2 minus 5a over b divided by 2a plus 3 over ab. And then if we go ahead and do this, well, I'll make this 2 over 1 and this 2a over 1 just to make the common denominators easier to find. So for this set of parentheses, the common denominator b, so b over b. And over here it's ab, so we need ab and ab. So what I have here now is 2b over b minus 5a over b divided by, so 2 times a times a times b is 2a squared b over ab plus 3 over ab. Then I will do the subtraction. All right, so it is going to be 2b minus 5a, all right, over b, and then divide it by, I'll do the addition here, so 2a squared b plus 3 over ab, and then I'll multiply by the reciprocal, so I'll have 2b minus 5a over b, then times ab over 2a squared b plus 3. And then if I see what happens, I can cancel out a common factor of b here, or divide out a b here. So then what's left is the 2b minus 5a times a, but I'm going to go ahead and distribute this a here. So it's 2ab minus 5a squared over 2a squared b plus 3. And that is my answer right there. What a time to be alive. All right, let's try another one here. So this is just a division problem here. So we have a minus b divided by b divided by a plus b divided by a. Then the adding and subtracting has already been done for us, so I just need to multiply by the reciprocal and do the division. So a minus b over b times a over a plus b, and then I see that there's nothing to be done here except for distributing the a here and distributing the b here. So I'm left with a squared minus ab over ab plus b squared. What a time to be alive. And you can see that that is the same answer. That is one of the choices I have here. So let's go ahead and try another example here. So I have a division problem again. So r minus s over 2s divided by s minus r over 6s. So the adding and subtracting has already been done for us. So I'm going to just multiply by the reciprocal here. So I have r minus s over 2s times, so that will be 6s over s minus r. And then I can divide out an s, and then I'll write the constants in front. So I have, actually, what do I have here? So I have 6 times r minus s over 2 times s minus r. And then I see that 6 over 2 is equal to 3. Then if you remember from our previous videos and discussion about factoring, you can rewrite the the denominator or the numerator. It doesn't matter which one. So you could write r minus s as negative s plus r. So just switch the order here. And then you can factor out negative 1. So it's negative 1 times s minus r. So this ends up being negative 1 times s minus r over s minus r. And then the s minus r's can divide out, and you're left with 3 times negative 1, which is negative 3. All right, so what a time to be alive here. Let's try another one here. So we have a division problem again. So it's x minus y over x squared plus y squared divided by x squared minus y squared over x plus y. So the adding and subtracting has already been done. So we'll multiply by the reciprocal. So we have x minus y over x squared plus y squared times x plus y over x squared minus y squared. And here we go. So now I will do the factoring of the x squared minus y squared, because that's a difference of two perfect squares. So I have x minus y over x squared plus y squared times x plus y over x plus y, x minus y. And then I will divide out the common factors. So here x minus y can be divided out, and here x plus y can be divided out. So we are left with, all right, so in the numerator, it's 1, and in the denominator, x squared plus y squared. So there is our solution here. So that here was indeed one of the choices here. All right, what a time to be alive. All right, so let's go ahead and do just a few more here. So here is another one here. So we have fg over 2 minus fg over 4, and then that's divided by fg over 8. So we have fg over 2 minus fg over 4 divided by fg over 8. So we need a common denominator. So what do we have here? So we have, well, between the 2 and the 4, a least common denominator of 4. So if I multiply by 2 over 2, I do get that these both would have a denominator of 4 now. So it's 2fg over 4 minus fg over 4 divided by fg over 8. And then 2fg minus fg over 4 will be just 1fg. All right, so 2 minus 1 is 1. So fg over 4, and then divide it by fg over 8. Then I'll multiply by the reciprocal. So that will be fg over 4 times 8 over fg. Then I divide out the common factors of f and of g here. So we have 8 over 4. All right, so 8 over 4, and 8 over 4 is 2. So 2 is the answer there. What a time to be alive. All right, so now let's try another one here. We have a division problem here. So we have x over x squared minus 16 plus 1 over x minus 4 divided by 1 over x squared minus 16 minus 2 over x plus 4. And then let's go ahead and do the factoring here. So x squared minus 16 is going to be x plus 4, x minus 4, because it's a difference of two perfect squares, then plus 1 over x minus 4, and then divide it by 1 over x plus 4, x minus 4, because x squared minus 16 is the difference of two perfect squares again, then minus 2 over x plus 4. And now I go ahead and I make the common denominators here. So for this first set of fractions here, I have an x minus 4 and an x minus 4 in both denominators. Now I need an x plus 4 in both denominators, so I'll make that happen right now. Then for the second set of fractions, I have x plus 4 here, and then I need both of them to have x minus 4, so I will make that happen right now. All right, so now let's go ahead and add here and subtract here. So I have x plus 1 times x plus 4 over x plus 4 and then x minus 4 divided by 1 minus 2 times x minus 4. So don't forget this minus right here. And then all over x plus 4, x minus 4. And then what I will do is I will go ahead and simplify in the numerators and denominators here. So if I distribute that 1, then that's not really anything to too much worry about, but I do need to distribute this negative 2 correctly. So what do I have here? I have x plus 4 over x plus 4, x minus 4, and then divide it by, all right, so 1 minus 2x plus 8 over x plus 4, x minus 4. And then I will go ahead and simplify. So x plus 4 is 2x plus 4. And then I have x plus 4, x minus 4 in the denominator. Then divide it by 1 minus 2x plus 8 is 9 minus 2x over x plus 4, x minus 4. And now that I've done the adding and subtracting, I can go ahead and I can just multiply by the reciprocal here. So I have 2x plus 4 over x plus 4, x minus 4, and then times, all right, x plus 4, x minus 4 over 9 minus 2x. So go ahead and try to simplify that if you dare, all right, because it's not too difficult. Hopefully you can see you can divide out a common factor here of x plus 4, and you can divide out a common factor here of x minus 4. And what are you left with? Well, you're left with 2x plus 4, and that's over 9 minus 2x. Or you could write it as in the choice here, instead of 2x plus 4, it could be 4 plus 2x, and then still over 9 minus 2x. So there you go. That is the answer to this one. All right, let's do just this last one here. All right, so this will be our last one, unfortunately, and it's another division problem here. So we have 1 over z plus 2 over z, and then divide it by 3 over z minus 4 over z plus 2. So then I need to make sure that I do the adding in the first set of parentheses and the subtracting in the second set of parentheses before I move on to doing anything else. So here I see that the common denominator is z plus 2 times z. So I'll multiply by z over z to get each denominator to have a z, and then by z plus 2 to get each denominator to have a z plus 2. So it's really just, here we go, all right, z times 1z, and then plus 2 times z plus 2, and then divide it by. Here, similarly, I need both denominators to have a z, and both of them to have a z plus 2. So z plus 2, z plus 2, and then a z and a z, all right? So now, in the numerator, I have 3 times z plus 2, then minus 4z, all over z times z plus 2. And then let's simplify the numerators of each of these fractions. So I'll distribute the 2 and distribute the 3 here. So what do I have? I have z plus 2z plus 4 over z times z plus 2. Then that will be divided by 3z plus 6 minus 4z over z times z plus 2. And then let's simplify here. z plus 2z is 3z, so I have 3z plus 4 all over z times z plus 2, and then divide it by 3z minus 4z. That will just be a negative z, so I can write it as negative z plus 6 or 6 minus z, it doesn't matter which one, and then all over z times z plus 2. And then I'll multiply by the reciprocal now that the adding and the subtracting is done. So I have 3z plus 4 over z times z plus 2 times z plus 2 divided by negative z plus 6. All right, what a time to be alive. And I can divide out the z's. All right, and then divide out the, well, what, I need a different color pen. What a time to be alive. Divide out the z plus 2's, so you can see I'm left with the 3z plus 4 over negative z plus 6, or if I rewrite it so that it's in the same form as my answer choice, 4 plus 3z over 6 minus z. Alright, what a time to be alive. I really hope that you enjoyed this video on complex fractions, and I hope you're already looking forward to the next one. Thank you and have a great day.